So these are going to be triangle congruency proofs using those vocab words we were practicing on Friday. Here are some tips for completing these proofs. So you're going to want to fill in one given at a time. Each time you mark one, you are going to want to mark your figure as well. If there's a vocab word listed in the given, like midpoint, bisect, perpendicular, you're going to have to use that word to mark something, and you're most likely going to use definition of that word as a reason to fill in your proof, except for parallel, because we talked about when you have parallel lines, you're looking for an angle pair. If the proof is still incomplete after you've used your givens, including your vocab, then you're going to look for vertical angles or a reflexive line. And then after each triangle has a combination of 3 sides or angles marked, you're going to look at the diagram and figure out which shortcut you used. So here's our first example. So we are going to start these just like we did last week. We're going to write in our given statement. So LM is congruent to NP, and we write the word given, and we mark the figure. Since these are sides, I'm going to give LM and NP both one congruency mark. The second given is LP is congruent to NM. Again, the reason is given. LP is the second side, so we double mark, and it corresponds to NM, so it also gets a double mark. After that, I'm out of givens, so I either look for vertical angles, which I don't have, or a line that the triangles share. And these two triangles share line NL, and so I write NL is congruent to NL, and we call that reflexive. Since this is the third side, I would give it 3 marks. And now that I have a combination of either 3 sides and 3 angles marked on each triangle, my proof is complete. So now I can prove that triangle LMN is congruent to triangle NPL. And if I look, I marked 3 sides. So this is side, side, side. For this next proof, I start very similar. So the first 2 statements are just marking sides. So I have IE is congruent to GH. So I mark both of those with 1 tick mark. Then I have EF is congruent to HF. Again, given. It's the second set of sides, so it gets 2 marks. And then the last given is F is the midpoint of GI. And since this is still given, I write given. Now, I have to mark something using this information, so I'm going to go focus on GI. So here's GI, and I know F is right in the middle, which means it gets split into 2 parts that are the same size. So if you look, IF is that first part, and then FG is the second part. So that's right here, and then right here. So I want to write down that those 2 pieces are congruent. So IF is congruent to FG. And we can mark those. This is the third side, so I'm triple marking. And that's just the definition of midpoint. So midpoint means it's in the middle. That means it's split into 2 congruent parts. After I do that, if you look at our triangle, we have 3 sides marked on each one. And so I'm finished with my proof. There are vertical angles in this proof, but since we could get all of our marks with the given, we don't actually need to add the vertical angle part. So we're just going to stop our proof here, and it's side, side, side. For this next one, we're starting off with angle M is congruent to angle K, and this is given. We mark angles with the arc mark, so it looks something like this. Then we're also given WM is parallel to RK. That's still a given. So I'm going to mark WM and RK with parallel marks, which are arrows going the same direction. Whenever you're given parallel, your mind should start thinking, I'm looking for some kind of an angle pair. So if I highlight these two parallel lines and the transversal that goes with them, you can see that I have outlined two angles. So I've outlined an angle here, and then I've outlined an angle here. And if you're having a hard time recognizing it, you can always kind of sketch yourself a little picture out here. And hopefully you can recognize that these are alternate interior angles. So that's the reason that I'm going to write. And I need to name the angles with 3 letters. So remember, your vertex is always going to be the middle letter. So for this angle right here, W has to be my middle letter. So it's going to be M, W, R is congruent to. And then if we're looking at the other one, R needs to be the middle letter. So K, R, W. Now, I am out of givens. I do have 3 things marked on each triangle, but those parallel marks don't technically count as marking a side. So now I need to look for vertical angles, which I don't have, or a side that the 2 triangles share, which is WR. So lastly, WR is congruent to WR, and that is reflexive. And now we have all of the marks we need. So I can prove that these 2 triangles are congruent. And if I look, I've marked 2 sides and, 2 angles and 1 side. So here are my choices: angle, angle, side, or angle, side, angle. And if I look at my diagram, the side isn't right in between, so it would be angle, angle, side. For this next proof, I start off with angle V is congruent to angle Y, and that's given. And I go up to the figure and I mark my angles. Next, I have WZ bisects angle VWY. Anytime you have a given, you copy it down exactly as is and you write given. And then from there, we need to figure out how to mark it. So remember, bisect means cuts in half or into 2 equal parts. So in other words, WZ cuts angle VWY in half. So this angle is getting cut in half. So here's angle VWY. And then WZ cuts it in half. If you highlight all of that, you can see how up here we're creating these 2 smaller angles that are congruent to each other. So angle VWZ, that's this angle on the left, is congruent to angle YWZ, which is the angle on the right. And that we know because it's the definition of bisect. So again, notice that in our proof, if we have a vocab word, pretty much right after the reason's going to be definition of that word. Now, I've used both my givens. I still don't have 3 marks on each triangle, so I'm looking for vertical angles, which I don't have, or a line that the triangles share, which is this one right down the middle, WZ. So WZ is congruent to WZ, and that is because it's reflexive. Now I have 3 marks on each triangle, so I can prove they're congruent. And if I look again, I have 2 angles and 1 side. This side is not in between the 2 angles, so it's angle, angle, side. And then in our last proof, we have AB is perpendicular to BC and DE is perpendicular to EC, and that's our first given. Remember, perpendicular means right angles are formed. So where AB meets BC, that's a right angle. So make sure you're drawing a square, not an arc. So the right angles have to be squares. And then DE and EC, where they meet, is a right angle. Remember, when we have perpendicular, there's 2 things you have to put in your proof. The first is going to be that angle ABC and angle DEC are right angles. And that first one is definition of our vocab word, which was perpendicular. After that, we have to say angle ABC is congruent to angle DEC because all right angles are congruent. Now, I've used my first given, but I haven't written down this second one yet, so I'm going to write that one next. Sometimes when I'm on a certain train of thought, I like to finish it and then go back to my givens if I need to. If you like to write all your givens at once, that's totally fine too. I just prefer to get one train of thought out of the way and then go back and finish it. So this given says side AB is congruent to side DE. So those both get 1 mark. Now, I'm out of givens, so I look for vertical angles, which this time I really do have. So this angle here is congruent to this angle here. So if I name those, C needs to be the middle letter, but I have to use 3 to name them. So the one on the left would be called BCA, and that would be congruent to ECD. And that is because of the vertical angle theorem. And then lastly, I have a combination of 3 sides and angles on each triangle marked. So I'm done with this proof. And if I look, I have 2 angles and 1 side. So my 2 choices are angle, angle, side, or angle, side, angle. Some of you might have seen the 90-degree angle and thought, oh, this is definitely going to be HL. But if you look, across from the right angle is the hypotenuse, and there's no mark here, so it can't be HL. I know that this has to be angle, angle, side, because the side isn't between the 2 angles.